Well, I think we can get started now. Hola and good morning, everyone, and welcome to the GCOOS Spring Webinar Series entitled The Southern Gulf of Mexico Marine Observations, Research and Technology, Opportunities for Gulf-Wide Synergies and Cooperation. I'm Jorge Brenner, the Executive Director of the Gulf of Mexico Coastal Ocean Observing System. At GCOOS, our mission is to provide on-demand information about the Gulf open and coastal waters that is accurate and reliable, that benefits people and ecosystems and everything that we care, as well as our economies. We appreciate your continued support and interest in this spring series. This webinar series continues to serve our communities in the United States and our colleagues in Mexico. It's focused on marine observations, scientific contributions, technical innovations developed by two marine consortia in Mexico. First, SIGOM, the Gulf of Mexico Marine Science Research Consortium, and second, CEMIE Océano, the Mexican Center for Marine Energy Innovation. This session today is focused primarily on CEMIE's work on renewable energy in the Gulf of Mexico, as well as on the Mexican glider. Just a few things before we get started. Please mind that this event is being recorded. So if anyone has any questions, just please let us know. Recorded presentations will be available in our Zoom page, YouTube page in a few more days after this presentation is ready. With this webinar, we complete the series of webinars that we've organized for the spring, and we hope that you become very interested in this. So with this, I'll pass it to my colleague, Sharon Herska.
Good morning, everyone. We're very, very excited to have you here today. So we have four fantastic presentations that do a wonderful job of representing some of the work that's being done in Mexico. And we are going to have each of the presenters give us a 10-minute talk, and we're going to have all the questions at the end. If you have questions as they are presenting, please put them in the question tab that is on your GoToWebinar control panel, and then at the end, we'll help the speakers address those questions. So the first speaker is Dr. Edgar Mendoza. He is from the Engineering Institute at IIUNAM in Mexico City. He's head of the hydraulics department and also runs the Coasts and Ports Laboratory.
Thank you very much, Sharon. I want to thank the organizers for the invitation, and also to each one of you for your attendance to this webinar. I hope that you find it interesting, and most important of all, that we can find some collaboration ways between our institutions. I have a few minutes to show you some of the devices that we have been developing in the CEMIE Océano. In the last, we could say 4 years, but some of them have been working for a little bit more than 4 years, probably 5 to 7 years. And unfortunately, I cannot show you everything that is being done in the center because of the time. But I wanted to show like a panorama of the things that we are working on as a whole group, and of course that we are divided in small subgroups. But the work is being done by all the group, which is formed as you will see in the next slide, which is like trying to contextualize the CEMIE Océano. Is a effort from our federal government in putting together all the capabilities of national institutions, private and public, enterprises and universities, and all the people that could be involved to push the development and the placing of plants in order to get some marine energy to our national energy matrix. So this made the center to be a very big consortia, and we have a lot of participants, as I was saying, from the private sector and from the public sector and universities and some companies. And we have also some external and international advisors. And we are now shifting into a new scheme in which we are also very prone to collaborate with the private and with international partners in order to get our goals. Just as a small introduction, I wanted to show you where more or less we are standing up as a center. This slide shows a qualitative comparison of the development that we see in Mexico of the different technologies related to marine energy, and compare qualitatively to wind and solar terrestrial energies, and obviously fossil fuels. And it is obvious that the conservative or the traditional ways of harvesting and converting energy into electricity have a lot of development in advance to marine energy. So we have a lot of work to do. We have a lot of research and development to do. And that's why we are working in very large groups and also in the small groups. And we are trying to put interest to almost any concept and any idea that comes from our partners. And we are not trying to pre-select, but to try to be serious with any concept and any idea, because we have a lot of things to do and to, let's say, we are not willing to buy technology, but to develop our own technology and to have technology designed specifically to our conditions in the Gulf of Mexico and in the Caribbean Sea and in the Pacific coast of our country. So what is very important for us now is that a lot of our actual developments fall maybe in this part of the curves. What you are seeing there is a common relation between the technology readiness level and the investment needed to continue, let's say, upscaling the technologies and maturing the ideas. And our ideas and our concepts are mainly in the polygon I have just drawn. And that means that we are in the need of a lot of collaboration, and that it is very sure that in the next few months and years, we will also need the complement from investment from the private sector. In Mexico is almost private sector, but maybe if we can collaborate with some international partners, we will be able to do so with, let's say, fundings from different sources. So that's more or less the state in which we are now. And as a summary, separating by energy source in the marine context, this can apply to a lot of countries, but it's mainly focused on how we see the things in Mexico. And the technologies to convert the tidal energy are more or less developed, so we can more or less easily walk into real demonstration and implementation of projects. For marine currents and waves and OTEC, it is probably 2 steps behind, and we are developing the technologies and trying to grow in maturity, each of them. And probably salinity gradient is the least in development, because it's the youngest, let's say, technology also. And we have some projects, but in an incipient stage. So we are trying to find a way to accelerate all the technologies and all the sources to be able to offer to our authorities as soon as possible some percentage of the electric matrix of the country supplied by marine energy. So I will show you some of the devices that we have been working on in the last few years. This is a first approach that we did some years ago, which is a WEC cloud blow called, we name it BlowJet. And the idea of this WEC is mainly to have the least possible moving parts. So we designed a conic element resembling the tuba, a brass instrument, and we try to optimize its geometry. We are still working on optimizing the geometry. It is also in the way of being registered and patented. And so the idea is to have let's say, a Venturi system in which the velocity of the flow that goes into the device could be double or triple at the output, and then have a turbine to generate. This is a very simple concept, and that can work in several places, fixed to, let's say, a boiling water, or that can also be independently floating. Another wake that we working was oscillating water column, which is not a single column, but the idea of this device is to have several columns connected or interconnected, so that one can get the best from the pressure inside each chamber, instead of having independent chambers that can work or let's say not using some part of the energy. In this case, we are looking for an arrangement that can be distributing the pressure and the generation all along the chambers and have a better efficiency of all of them. As I was saying at the very beginning, these two concepts are reaching a maturity or a readiness level between 2 and 3, and we are trying to develop them. Some other ideas, this is another oscillating water column that has inside a Wells turbine, so this is not getting benefit from the air pressure, but from the water movement. We have also developed another floating device that is attached to an arm, and with the up and down movement can generate electricity. We are testing different shapes and geometries of the floating body. We are working on, regarding marine currents, we are working on turbines specifically designed for slow speeds, which are the ones that are mostly found in Mexico, in the Caribbean Sea, and also in the Pacific. We are also working on the design of turbines, but with the principle of biomimetics. So we are trying to reproduce for the blade of the turbines the wing of the oak bird, which is a bird very similar to a penguin, but is not of the family of the penguins. But this is a bird that can fly in the air and also, let's say, fly in the water. So we are doing some work to replicate the shape of its wings into the blades of a turbine. And as I was saying at the beginning, we are also developing a reverse electrodialysis plant for salinity gradient conversion, which is part of our research, basic research, which will very promptly be coming into development. And in Cozumel Island, we have almost working an OTEC plant of 1 kilowatt, which is placed onshore. It's a closed cycle, and this plant is going to be used for research and for development, and to show that OTEC technology can be set in Mexico. And we have some ongoing work, mainly related to upscaling all these projects and to putting all these ideas into readiness levels from 5 to 7, and let's say putting them ready to expect from private investment. And I want to stress that we are, the group as semi-ocean is also working very hard in the part of materials and coatings for corrosion resistance of our ideas and devices. The time was very short. I just could make a very simple panorama, but there is my email, and any question we can answer it at the end. And thank you very much for your attention.